Hello. So it seems that I might have been a little bit too pretentious with the title, which might result in not so many people coming here. Of course, in a Java conference, getting the best of JavaScript and of Scala might not really give you a good first impression, but I'll try to convince you nevertheless. So I'm going to talk about Scala GS, which is a dialect of Scala that compares to the JavaScript platform. And when we mean JavaScript platform, it's anything where JavaScript runs. So that might be the browser, but also Node.js or AWS Lambda or the command line with Node as well. So pretty much anywhere. And to give you a feel of what it means to develop in Scala.js on a daily basis, I will basically do a live coding session. So this is about my only slide. I also have a conclusion slide, but that's it. Okay, so without much further ado, let's go to my development environment, which is Eclipse. I'm one of the few remaining people in the Scala community using Eclipse. And what we are going to develop today is this simple memory game, also known as pairs. And of course, for that, I need to launch my server. Oops. So here's my simple server running. Okay, so it's basically this thing where you're supposed to remember, oh, I got lucky here. And I have the score here, and basically that's it. So first things first, let's roll back. Go to the last commit with a good git reset hard. And phew, no code anymore. There we go. Okay. So I intended to do a show of hands in the big... Oh, yeah, if I clean up the lights, I can see you. So let's see. Who among you still uses or has ever used a language that compiles to JavaScript and that was not JavaScript? Oh, a fair number of people. Among you who used Scala.js? Good, so you're all new. Someone said, yeah. Okay, excellent. So this is pretty much about the smallest program we could write. It has a main method, typical. It gets the document, creates a P element, sets some text content. So as if you're familiar with JavaScript, this should be fairly reminiscent of the DOM API, and for good cause, it is the DOM API. So if I now refresh this guy, all I see is this tiny hello, which you might not even be able to read. Okay. So since I'm not really a front-end developer myself, I'm going to follow up a tutorial because I don't know how to write games. So I used this tutorial about Phaser. So Phaser is a JavaScript library, which is intended to be used for front-end game development. And I'm basically going to follow this tutorial, which was, of course, written for JavaScript developers and implement it in Scala.js instead. And we have 46 minutes left to do this. So that is the server part. I'm skipping it. The HTML part I have done as well, because that's boring. Here it comes. So apparently I have some event loop thing with a bunch of methods for the life cycle of the game, a preload, create, update, whatever that means. I want to see the code. Here, some code. Okay, so let's copy this. So until there it seems. And let's copy that right here instead of my main method. Of course, it doesn't really like it because that's JavaScript. So here there seems to be a class declaration. So let's move it here and fix up the type errors. So instead, I'm going to have a class game. So of course, that tutorial was written in the ECMAScript 5 era. So classes are declared as functions of prototypes, but we prefer actual classes. And I'm going to declare a preload method, which is returns unit, which is kind of void in Java. And then I have 3 more like this: create, update, and render. Okay, so that part we translated. I can remove it. And this guy should be indented. Okay, so now, of course, no semicolons in Scala. And we prefer immutable vals most of the time. Okay, so now, of course, I'm supposed to instantiate that class from Phaser, which is that JavaScript library. And Scala, being a statically typed language, doesn't really know about this thing. So it tells me, the Phaser is, I don't know what this thing here. So we'll have to help it a little bit and give it some information about what this JavaScript library is. So I'm going to create a Phaser object in a subdirectory, in a subpackage. And since that guy is going to declare a bunch of things from the JavaScript world, I need to import the right tools for this. Now I can say, okay, this Phaser thing, I'm not going to actually implement it right here. It's just some types, some declarations from something that's written in a native JavaScript library. And so I annotate it with @JS native. And then I have some additional stuff to declare the fact that it's this JavaScript object, not a Scala object. And also I need to tell it where to find it. It's native, but where is it? Well, it's in the global namespace. So Phaser just puts a global variable named Phaser in the global environment of JavaScript, and I'm telling it, there it is. Okay, so that should at least tell it that, I need to import, of course, this thing. So I have Phaser _. So now it knows about Phaser, but not about game. So game apparently is a class because it has a new constructor. But let's verify this. So I have here the API documentation of Phaser, and I'm going to a little bit translate this API, which is given to me as a form of documentation online, and translate it to actual type declarations that Scala.js can use. So of course, this library is huge. I don't want to spend 4 hours now translating the entire API documentation in the types and not getting any work done, right? So I'm going to do that in a very iterative way where I just declare the parts that I need right now and then continue on. That's typically what people do. So it has a bunch of things, but from the tutorial, I only need apparently the first 4, so I'm just going to use those. And so this one, this one is of course also a native class game, and it has those parameters, but of course it's a typed language, so I guess width and height should be integers. Renderer, by the looks of it, oh, it tells me here that's a number. I guess it is an int as well. And a parent, which the documentation says is a string or an HTML element, but let's go for string. Okay, so that should let me instantiate that thing. Okay, we're getting somewhere. This is of course not a correct Scala string, so let's use Scala strings. And now it's still not quite happy with phaser.auto, which apparently is a constant. So let's declare it as a constant. So this is this guy. Apparently I'm giving it to renderer, so it must be an int, I guess. And so there is a little bit of guessing game at this point, because I'm using a JavaScript library which is completely untyped, following a tutorial that was written for JavaScript which is also untyped. And so of course I'm trying to give a little bit of guessing here. But the good point is I'm showing this right now because at some point people want to call a JavaScript library that nobody has written bindings for, but usually you just import a library that someone else has written bindings for, so we don't actually deal with that stuff all the time. Okay, so I got a bit further. I'm going to complete basically that part using all this manual stuff of doing everything. And after that, I'm just copy pasting what I did before, because that's going to be annoying really fast. So it seems that on this game thing, there is a state field. And from the documentation that I looked at before, it's basically a state manager, which is another class. And that one has some methods. So we have here an add method, which I think has a key or a name, which is string, and some constructor, some class that represents the constructor in JavaScript. And that's a really JavaScript-ish thing. We don't really have a good type for this, so I'm just going to use JS Dynamic, which is just any JavaScript thing that we don't actually statically type. We just leave it as dynamically typed. Yeah, I should make that bigger. Okay. And the other one was start. So we have start, which also takes a name, which is a string, and is also native. And then this should compile almost, except that this thing here, so this is a caveat of Scala.js, the fact that in JavaScript, a class is also a value. It's a thing that you can hold, that you can give it somewhere. In Scala, you have two different things. You have the types, and then you have the objects, and the class is a type. But if the class is a JavaScript class that extends JS object, for example, you can just ask for its value in JavaScript using this construct. And now it's just not happy with this guy because I forgot that part. Okay, that should be good. It seems that it compiles everything. Okay, so that's my server running. That's my build tool being recompiling all the time I save. So you didn't really see it doing anything, but it compiled the JavaScript file. So all I need to do is refresh. And yoo-hoo, we have a black rectangle. Sound good? Yay. Oh, someone applauded there. I'm really happy. Okay, so I seem to notice there is not much of a culture of questions during these talks, but if you feel like asking questions, just shout. Don't raise your hand because you're all in black for me, so I don't see you, but you can shout question, and I'll answer. Good. Okay, so let's move on to more interesting things. We can finally go back to our tutorial here and go further. So here they're explaining a bit of things, a bunch of things, but I'm not really interested in understanding what I'm doing. More like in get results. So it's good, let's just focus on the code. And apparently there is this preload function, which seems like it's loading some assets, some files. So let's copy that and put it in our preload function. Okay. So, of course, it doesn't really like it. So I don't really like those repetitions here, so I'm going to use a loop instead, but let's get back to that after. Let's just first fix the syntax, because otherwise it's really annoying. And there we are. Okay, so now we have type errors, of course, because this .load, again, is not declared. But at this point, like I said, it's going to be very annoying for this live coding session to repeatedly go inside my declarations and add relevant things. And anyway, that's not typically the experience that you feel unless you're using some obscure library that no one has written binding for. So I'm going to just take those I wrote earlier and copy paste them here. Ta-da! And now I have this load thing here. So now actually Phaser, it takes your game instance and turns it into a state. So effectively, your class game can actually extend Phaser.state. And it will then have this things like load. And so this one, if I jump to definition, it's right there inside the abstract class state that just declares what Phaser is giving me as tools in my state game. Okay, so that load is a loader that has an image function that I guess loads images. So I can use it like this. Seems to type check, which is good. But now we had this thing here, so I'm going to just use a loop from 0 until 10. So until says from 0 included until 10 excluded, so effectively from 0 to 9. And I want to use i.toString here. And here, let me use a string comprehension to get the I. So the $I inside the string comprehension says, takes the value of the variable I and turns it into a string. Okay, so this probably doesn't do anything because it loads assets. So this is just the same as before. But since it's JavaScript, if something went wrong, we wouldn't know about it. So let's just look at the console. Seems nothing's wrong. It just says Phaser with love. It's not very helpful. Okay, so so the nice thing here is I'm starting to get some. It probably didn't show really big. I never understood how I was supposed to enlarge the auto-completion box for presentations, but I get these type-checked auto-completion from my IDE, so I can just use those things even in JavaScript, and I get all the goodies. So that's quite nice. I can also do without this, because in Scala, like in Java, this is implied, contrary to in Scala in JavaScript. So that's a little bit nicer. Okay, so let's go further. And no, my tutorial is here. So I think now we're getting to the part where something is going to show up on the screen, which would be nice. Yeah, so it seems that they're creating things. So let's create things. I like copy pasting. Create. Okay, so apparently there is here a for loop in JavaScript that's very imperative. It has a variable. I don't really like variables if we can avoid them. So, and anyway, it's trying apparently to add 2 sprites, 2 per digit from 0 to 9. And that's of course because in the pairs game you're supposed to have 2 of each, right? So instead, let's declare the numbers that we need. And that would be 0 until 10, and a second time 0 until 10. So that thing here would be a sequence of numbers. So that would be 0, 1, 2, 3 until 9, concatenated with, again, 0, 1, 2, 3 until 9. So that plus plus here is a concatenation of arrays or sequences or whatever you want to call them. So now that I have my numbers, I can create my images. So the images not shuffled would be something like, for each number, I'm going to need one sprite. So I will have this.game.add.sprite, copying here 0, 0, and the key is empty string plus I, which is actually numbered at 2 strings. It's a little bit better. Okay. So here, instead of doing images.push and creating a mutable collection and fill it in, I'm just using a for comprehension here, using the yield keywords, which, I mean, I'm going to lie a little bit here, but it basically executes this a bunch of times for each number in this thing, and each time it gives you the result of that expression, and it will return you a list with all these elements. So now here it says I have an index seek of phaser.sprite. So you can see that I'm not actually writing any types most of the time. That's Scala type inference working for you, but I could as well. So just for the sake of it, let's write here an index seek of phaser.sprite, and it's just it also type checks. It's a bit more explicit in this case because it's a bit complicated, so it's better to follow. Okay, then so I did that part. Now I need to shuffle these images. Apparently in the tutorial they provide a shuffle function, but Scala has one, so let's reuse it. So I'm going to take the, whoops, not that one, util random shuffle of images not shuffled. And yay, I have a shuffled collections of my images. Good. Okay, so now it's that's the placement part. So let's do also a double loop like this, except that in Scala we can combine them. It's a bit better, arguably. 0 until 5. And so, okay, let's translate things. So I have items 5 plus j. Then I have my cards. So cards is the back of the images. So images is all the fronts. I'm also going to create, so here again they're creating the collection of cards one at a time, but I'd rather do it in a functional way right from the start. So for each image in my images, I also want another sprite, which will be also at 0, 0. And its key will always be back. So that's the back of the card, the one that shows a question mark. We don't know what it is yet. So now I can do val card equals cards of index, and I can position it. So I can tell it it's positioned at j times tile size. So I need, of course, to declare tile size. This is a constant, and trust me, it's 130. Okay, we're getting there. The tile size, and I think if we stop there, we should see something. So let's, for the sake of making the presentation a bit more lively, have a look at the code results right now. Yay! Okay, good so far. Any questions? No? Okay, let's continue. So let's uncomment this. So I also need to position the front card. So images, so val image is images of index, image.xj times tile size, image y I tile size. And the front I want it to be not visible. And then I also need to declare some events here, because of course it needs to be a little bit interactive. So the back of the card needs to accept inputs. That's an optimization from Phaser that if a sprite doesn't have input enabled to true, it will just bypass it in a bunch of input related processing. Then there is this events thing, and I can say on input down.add. So I'm just following the code from here, right? And here I have a listener, which is a function which takes no argument and is going to do something. For now, I don't know quite what, but it should probably have the index of the card. And I'm just going to declare it right here. So of course that should not be visible to the outside. So let's keep it private. Okay. And then I have two more, which is events on input over. So that one happens when you put the mouse on top of the sprite. And here I'm going to use the other syntax for functions. That's a little bit better when you have multi-line functions. And in this case, I want that card to change its alpha value to 0.5, which of course will have the effect that will be halfway transparent when we put the mouse over it. And when the mouse exits it, we want to restore the alpha value to 1. Card alpha equals 1. Okay, so now we should have translated the whole of this guy. So let's remove it, and hopefully we can at least see the hover effect. So I refreshed too early. It wasn't done recompiling. Now it is. So now we have this small effect here. Okay, and it's basically all type checks so far. So you can see that now that we actually have a declaration for those for that Phaser library, we just interact with it just as it. I mean, with any other Scala or Java or library, and we get all the good features of the editor. Okay, so basically now we're on for the real part of the the game logic, which happens when I click on one of these cards. So here, obviously, I want to first hide the back of the card and show the front of the card to reveal it. So the current card should be cards of index. But of course, I haven't really declared cards here. It was declared here, but that's a different scope. It's a different function. So one thing I could do instead of putting this here in the class is I could instead put it right here as a local function. That way it has access to my deck of cards here. Another possibility would have to turn cards into a field of the game class, but that would be a little bit. I would need a variable for that, and Scala don't like vars. So I'm completely lying, by the way, because I'm doing lots of mutable states interacting with the library anyway. So this is we're not being functional at all. Being very pragmatic about these things. For some definition of pragmatic, of course. Okay, so I can also fetch now the front of my card, and I will of course hide this one, hide the back, and instead, yeah, I'm using the names of the of the tutorial, but I don't really like them because I never know which one is the back and which is the front. So let's rename that. So back visible is false and front visible is true. So if I just take this, now I can flip cards, but of course I'm not actually playing the game. So let's continue. One thing that I want to test is, well, it depends now. I have several cases. Either I just clicked on the card, the first card, and it needs to show up and wait for me to click on a second one to test whether they're the same. Or I have clicked on the second card and then it needs to compare them. And if I was wrong, put them back. And if I was right, increase my score. Or I could already have flipped two cards, but it could still be in a state where it's showing them to me for for 1 second or so, and waiting until that second elapses to hide them back and let me guess something else. So I have three kinds of state that I could be in. So I'm going to declare those things. And for this, I'm going to use a sealed abstract class, which is basically a hierarchy of classes, and I have a couple variants, but not any other variant. So one thing could be I made NoGas so far. Let's call it guess state. It's even better. So either I'm making no guess right now. I'm waiting to click on my first card, or I could be in the wrong guess state, where I have clicked on both cards and they were not identical. But then there is a case in the middle, which is I have clicked on one card and I'm waiting to click on a second card, but then I need to remember which card I clicked. So here I'm actually going to use a class which is one card, let's say, and then I can store the index of the card that I have clicked. So this here says that if I have something which is typed as a guess state, it can be exactly one of those three things. It's either a no guess or a one card with an index or a wrong guess, but it cannot ever be anything else, because that class is sealed. So no one else but me can extend that class. Right, so the question is, why wouldn't that be a trait? You can also make it a trait. I have a tendency to use sealed abstract classes when I can, because they're sometimes more efficient than sealed traits, but it's a purely me thing. So let's roll with sealed traits. Okay, so it's also the fact that everyone understands what a class is, and in a Java conference, people might not know what a trait is. So for the purpose of this talk, a trait is an interface, basically. Okay, so now I need to store my state. So this time, there's no way around it. I will need a variable. So guess state, which is a guess state, and it starts as a no guess. Let's put it with the other fields here. Okay, so now when I click on a card, I can test in what state I am. So I'm going to do what we call pattern matching, which is a bit like a switch, but for sealed traits, kind of. I'm simplifying things. So either it's no guess and I need to do things, or it's a one card and it has an index. Yeah, it shouldn't use index because I already used index. So first index. And if I forget one, it will actually tell me. So here the errors tell me match may not be exhaustive. It will fail on the following input. Wrong guess. So it can tell me that I handle no guess in one card, but I don't handle wrong guess. So I also need to handle wrong guess. So if I'm in the wrong guess state, what I'm supposed to do is, well, not allow the player to flip a third card at the same time, right? So I'm just going to return from this and wait for the next time that the player comes back after the timeout has elapsed and the cards are flipped back to their... In the no-guess state, that's also an easy one. I basically just need to store that I'm now in a state where I have one card. So my guess state is going to become one card of the index I clicked. And that's about it. The hard part, where all the game logic is, basically is the one card case. So here I have two possibilities. Either it was the same card as last time, or it was not the same card as last time. So for that I need to find not the index, because the index is the position on the grid, but I need to find what's the number of that card. So how can I know that? That is a good question. Oh yeah, there was a trick that I can reuse the key. So the first number was the images of first index dot key. Key is actually this guy that I gave. So every sprite has a key which uniquely identifies it to phaser, and I can just reuse that one. In an actual code, I would probably find something more clean than that, but yeah, whatever. And I compare it to the key of front, so the front of the card I just flipped. And if those are equal, then that's a good guess. If it's a good guess, all I have to do is restore the guess state to being no guess and increase some score by 50. I haven't declared score, so I need to do that. Score is an int. It started 0, 0. And otherwise, I need to put the guess state in the wrong guess. And I need to remove some points. And then I need to wait. I need to wait for about a second and then flip them back, both. So the easiest way to do that right now is to use a set timeout with 1,000 milliseconds. And in 1,000 milliseconds, I want to do something which is restore the state to no guess and flip back the two cards. So yeah, let's call it first. Oh, let's not do that. So I need to flip back my card, which is back and front. So back would become visible again and front would become invisible. And also I need to do that with the other card, the one from the first. So images of first index that visible equals false, and cards of first index that visible equals true. Okay, that's it. Anyone spotted a mistake before we try to run it? No? Good. Apparently the type checker didn't either, so let's try. I click on one, doesn't do anything. I click on the second one. Oh, they're wrong, they're back. They're flipped. Oh, I get lucky. This is the right one. Yay, awesome. Cool, so it seems to work, and if I try to click rapidly on this third one, it doesn't let me. Good, so the only thing left is that I haven't displayed the score. So let's see how they do that. I have kind of not followed the tutorial anymore. I know it by heart, I guess, by now. So that we did. Do click, we did. The game logic, we did. And update. Where's display the score? Ah, here's score. Okay, so they're doing something with debug text that probably is not the good way of doing it, but that's what they do. So, and they do that in render, which is going to be called like 60 times a second or something. It doesn't like that. Yeah, first I need to fix the syntax errors. Okay. So it doesn't like that because value debug is not a member of game. Right. So let's have a look at game. Right, it doesn't have a debug method. Well, that's because I wasn't very careful. Right? I didn't really add all of the methods of Phaser. I just added a few that I was going to need. Turns out I forgot that one. Well, I could add it, but just for the sake of it, I'm going to cheat and go the untyped way. No. So I'm going to just cast this thing into a JS dynamic, and ta-da! It works. So now it's not type checking anything anymore. If I add some characters there, it's not going to complain, right? So, but let's just trust the tutorial. Hopefully that's going to work. So now that it has recompiled this thing, let's see. Oh yeah, it's displaying something. It's probably too small, but you can see here score 0. And every time I lose, I get some points. Yay, I got plus 50. And this is going to be very embarrassing because, oh, yeah, yay, 75. So I think the maximum you can get here is 500, but that's if you get really lucky and you get all the pairs right. But if you play well, you can always get at least 450. But yeah, that's not going to happen this time. Okay, so that's about what I had planned. So I'll ask one more time if there are questions at this point. No questions? Then I would ask something else. What else would you want me to code up right now that I haven't prepared for that game? Yeah, let's not change the game, but anything? Some idea? Nah. Sorry?
Double clicking on the same item.
Oh, what would that do?
Maybe, well, get the same index.
So right now, if we double click on the same item, nothing happens because that's the front side of the card, and that the front side of the card doesn't have click enabled, so it just ignores the click. I mean, what we could do is flip it back and cancel, but that would kind of defeat the purpose of the game. But I mean, why not? Let's roll with that. There doesn't seem to be a better option right now, so let's add. So now I guess we need to add some events to the front side of the card. So that would be here. So I would add image.onImage.onInputDown.add. So if we, yeah, right. So I have the index. So I guess well, first, yeah, we need to check that we are not, that we are either in a case where we have only one card flipped, because if the two cards are flipped, then we have a timer in progress, and I don't want to mess with that. So let's only allow that if the guest state is a one card, and we don't really care about the argument because it has to be indexed in this case. And if that's the case, I want to flip it back. So I want to not show the image. I want to show the back of it. And I need to reset the guest state to NoGas. Okay, so that should do it. except of course it's not happy because I have not dealt with the no-guess and wrong guess cases. So I'm just going to tell it that in this case, if it's either no guess or wrong guess, I don't want to do anything. So, I mean, here I do nothing. Okay, so that should be good. Okay, let's see. It's recompiling, done. So now if I have one card up, it doesn't work. Yeah, I haven't activated inputs. It does not have input enabled. So it's just ignoring this thing. Image.input enabled, true. Recompiling, done. Yay. Good. Yeah, seems like it works. Okay. Well, that's about it. So thanks a lot. And if you want, I'll take further questions or offline after. Thank you. The source code for this this application? Yes, it is somewhere. It is on my GitHub page. So I will probably have the opportunity to give that information somewhere to the conference, but in the meantime, that's here. So it's SJRID, which stands for Sébastien Jean-Robert Doeraene, or Scala GS Research and Development. And it's Scala GS phaser demo. It should be at the top of my repository right now because I've updated it recently. So here you have the full code. It's actually a little bit better because it has nice stars, a visual display of the score using a range of stars. And it has a fairly more comprehensive part of the phaser library. So the source code is there. Right, so the question is, where would we find more of those pre-translated libraries? So if you go to the Scala.js website, you have a tab at the top which says libraries, and there you have JavaScript facades. So here you have a bunch of libraries that have been done before, and that people have done by hand. So these are pretty well curated and high quality for Scala use. If you don't find the one you want here, so this includes things like Scala for React and Angular, for jQuery, for Vue as well, for a bunch of these well-known JavaScript things. I think there was one for D3. Yeah, you will. I mean, most of the really big JavaScript libraries you will find there. If you don't find the one you want, you also have definitely Scala, which has 600 of them. Those are directly and automatically imported from the TypeScript definitely typed repository. So those are more exhaustive. There are more of them, but they're not hand curated. So the quality might be a bit less. The Scala, they might not be as idiomatic to use from a Scala environment, but they're there. It's always better than having to write them yourself. Good. I think we're done. Thanks.